So that's the center itself. That's the machine Comet. A lot of partners, and it's NSF funded. It's pretty much mostly standard compute nodes, 2,000 nodes with about 46,000 cores of Haswell processors, and 72 GPU nodes, 36 with K80 cards in them, and 36 with P100s. So today I'll talk about some of the GDR testing on those nodes. Apart from that, it's a hybrid factory topology, FDR and interconnect. I'll also talk about the virtual cluster part of Comet, and that's where we'll be using MVAPICH2-Virt. So let me start off by just looking at the architecture, and if I've presented this before, so if you've seen it again, sorry about that. So basically, it's a K80 node architecture. We have two K80s per node. The GPU 0,1 can do peer-to-peer, 2,3 can do peer-to-peer, but not across. And so they're on two different sockets. And I think on the K80 nodes, the InfiniBand adapter is, I think, on the GPU 2 and 3, the same socket as that. So if you look at the OSU latency benchmark intranode, as you expect, if you're looking at the orange line there with the GPU 2.3, it's lower than the GPU 1,2 between the communication between those two. So the latency, if you're on the same socket, is 2.82, and the latency going across is 3.18 microseconds. But it's a pretty standard result from, this is MVAPICH2-GDR 2.2. I was hoping to get some of the newer versions installed, but the Comet OS is a little old right now, so we are going to be upgrading in a few months, and that's when I'll basically do a lot of updated benchmarks, which should improve some of these numbers, I think. In terms of internode latencies, again, you get, if you pin your CPU and GPU on the socket that's near the network, you end up with the lowest, which is about 2.27 microseconds, and it bumps up to 2.47 on the further. And just to make it interesting, the P100 node is a little different. The network is on the other socket, so you have 0,1 and the network card on the same socket, and then 2,3 is again can do peer-to-peer. So I just want to show the latency results look very similar to what you saw on the K80. So just to show the bandwidth, you can see if you're on the same, if you're on GPUs on the same socket, you end up with pretty good bandwidth. I think it's 12 gigabytes per second, right over that. And then it flattens out a little if you're going across. Similar thing with the latency. If you're going internode, you get around 2.17 microseconds, a little bit better than the K80 nodes. One thing I also tested was looking at the CUDA managed memory version of the benchmark, so that MVAPICH2 can do communication directly from the managed buffers, and you can see pretty good latencies when you do that. And similar thing with the all-to-all benchmark. Again, you see pretty good performance when you're doing the direct managed buffers. And going on to applications, I think HumDBlue is one of the benchmark applications that actually the users are running on Comet. So we do see them using MVAPICH2 and running on Comet. I'm just showing the hexagon benchmark with strong scaling. Again, this one, we started off with one GPU on a single node, going up to 2 GPUs, 4 GPUs, and then 4 GPUs on 2 nodes. You can see the scaling is pretty good, going out to 2 nodes with 8 GPUs. And this actually holds okay going out further too. I haven't updated the slide. Another place where we use MVAPICH2-GDR is to test the OSU Cafe. This is the Cypher 10 benchmark set, and this was also scaling pretty good, going out to 8 GPUs.
What does that mean, number of GPUs?
So
GPU chips?
Yeah, GPU cards.
So when you say 2, is that on one node?
That's on one node. This was basically going out to 2 nodes using all 4 GPUs on each. So going on to virtualization on Comet, we have 2 ways we do this. There are a lot of users who are using Singularity. It makes it easy for them to migrate like complex software stacks. A lot of them have Docker images, and they end up pulling it into Singularity, and then can use them on the system without much effort. In fact, it helps us a little bit because oftentimes these are complex stacks with almost 200 packages that we would have had to install in the past, but now it's in an image and it's a lot quicker. We also see this with sometimes with commercial applications where we don't have the source and they have a particular requirement for an operating system and a particular MPI. It's a lot easier if you can do it in Singularity. So this is getting pretty popular in Comet right now. So that's become the predominant way to do to use containers. But we do have the option of doing full virtualization of a node and basically set up a virtual cluster. So this is KVM based virtualization, and with SRIOV support. This is where if you're an expert user, you get root access and your own cluster within Comet, and we isolate the cluster with VLANs for the network and keys for the IB side of things. And pretty much user, actually typically this is a group that does it, like an open science grid kind of group, where they will be able to set up the cluster the way they want it with the stack that they want. And this is where I was testing the MVAPICH2-Virt with CentOS 7. So some of the use cases, the one on the left was actually a workshop where they were messing with the operating system stacks and the network stack and actually changing things. So it was perfect to put them in an isolated environment where they could break something and not affect the rest of the cluster. And of course get root, which is what they wanted. So that was a nice use case. The other use case is an open science grid case where basically they have their own software stack, and it's well tested, and they have a pipeline set up for handling all the jobs that come through. So that was an easy way for them to transition to Comet without having to change much. And this was Comet was one of the largest backend systems for them, and it was part of the big LIGO runs which discovered the gravitational waves. So going on, just an example, so you could run an application in a Singularity container and using MVAPICH. So I just tested a standard benchmark. This runs fine in the regular environment too, but I was doing this just as a scaling test and a comparison. So this benchmark basically uses just the GNU compilers with MVAPICH2, and you can see pretty good scaling for the numbers. And in terms of absolute performance, also it does pretty well. It's very comparable to what I get on the regular system. So if this usually doesn't happen where somebody needs MVAPICH within a Singularity container, but it it's possible if they have a workflow where some components are not installable on our regular setup and some components need MVAPICH, then at least we know that the performance is going to be okay. So in terms of MVAPICH2-Virt, I was testing this on a virtual cluster where we had 64 nodes spun up, and the original intent was to actually try out some co-scheduling optimizations, but I was using MVAPICH2 as the baseline MPI version to do all the runs. So our QEMU version is quite old, so that disables some of the optimizations that are there in the latest versions of MVAPICH2-Virt. So the numbers I have are not quite the best you'll get. I mean, I think we should be able to, as I mentioned, we'll be doing an upgrade. So when I do that, I expect these numbers to get better. But even without that version, we get pretty good latency and bandwidth performance numbers. And one of the applications that I was testing was the PSDNS benchmark, which is pretty intensive on a communication side, mainly all-to-all V kind of communication. And it's bisection bandwidth limited, and it scaled pretty well, going from 32 cores on 2 nodes out to 128 cores on 8 nodes. Actually, it goes, again, this also scales out fine further. One thing I should note is all these compute nodes, actually when we spin up using our virtualization framework, on the back end it is a regular job on the compute nodes. So if you log into Comet and do an SQ-P Virt, all the jobs in that Virt partition are basically virtual clusters on the back end. That's what is going on. So typically what happens is our prolog checks to see if it's a Virt partition job, then it's going to reconfigure the node and give you the SSD for the operating system installed and everything. So you can actually do that dynamically. And the user doesn't need to know on the virtualized partition, but that's what's happening on the back end.
So from the regular nodes, you can take a set of nodes.
Correct.
And convert
Yeah, so what happens is you run a command line to spin up, say I want to spin up 16 nodes on the virtual side. On the back end, what we do is submit a job with your allocation, and you get back the list of nodes from Slurm, and then the system will isolate those nodes using a VLAN and a P key, so that you now have your sandbox, and then you can install them the way you want them. And we also have a backend process that is synchronizing the OS that you've installed, so that the next time you spin up, you're not starting from scratch. You can basically start with the same OS that was already installed on those nodes. So you can power on the nodes and power off the nodes as you want. So getting to the summary, as you saw, the GDR, MVAPICH2-GDR numbers look pretty reasonable given our architecture. I think having 2 GPUs on different PCI lanes basically is, and having to go over the socket, inter-socket communication is impacting some of the results, but overall the performance looks good. Since we have such a flexible system with different hardware choices, so we have GPUs where we use MVAPICH2-GDR, then on the regular compute nodes we have MVAPICH2 and MVAPICH2X, and then on the virtualized nodes we have MVAPICH2-Virt, so everything but the KNL, I think. In terms of what's upcoming on Comet, we are going to be upgrading the OS pretty soon. Comet itself, and Amit's going to talk about it tomorrow, but it's going to be extended out to run through 2021. So we're taking the time to basically upgrade to the latest levels so that we can upgrade all the underlying software and get set for the long haul. So that upgrade's coming pretty soon, and once that happens, we will enable XPMM support and take advantage of some of the cool features that have come up in the new MVAPICH2 versions. The GPU drivers are probably going to be upgraded very soon. It's next week maybe. We have our summer institute going on, so as soon as that gets over, we will upgrade that, and that should enable CUDA 9 and some of the other optimizations. And I want to end by thanking the MVAPICH group for all the support over the years, and I'm sure Amit's going to talk about a lot of this tomorrow. It's been, I think, well over a decade that we've been using MVAPICH in our systems. Thanks.